In this video, we'll look at what it means to raise a term with an exponent to an additional exponent, and that's called the power rule of exponents. So taking something with an exponent and raising it to another exponent would look something like this first example, where I have 2 to the third power that I am then taking to an additional exponent. Since this has a numerical base, we could evaluate it on our calculator. I always recommend using parentheses, especially when you're working towards more complex problems. So I'd start by parentheses and then getting that 2 to the third and closing them, and then taking that to its an additional exponent. So I see I get an answer of 64. Let's look at where that's coming from. If we think about what 2 to the third means, that means 2 times 2 times 2, total of 3 times. But what's happening is that is all getting squared. And I know that squaring means multiplying something by itself. So I have one group of 2 times 2 times 2 times another group of 2 times 2 times 2. If we look at how many total 2's we're multiplying together, that's 6 2's. So the simplified exponent form of this is 2 to the 6th power. If I were to evaluate that on my calculator, 2 and then that caret key 6, I see that I get an answer of 64. So let's look at it with something that's not able to type on your calculator, something that has a variable base. Ooh, this is going to be a lot. X to the 5th means 5 x's, all to the 4th power. So if I were to expand that even further, I would get 5 x's times 5 x's times 5 x's, and then times, I'm gonna have to make this smaller to fit, 5 more x's. Whew, okay, so group 1, group 2, group 3, and group 4. So x to the 5th to the 4th power, so 4 total times of that. If we count up how many total x's that is, well, it's 4 groups of 5. So that would give me a total of 20 x's. So the simplified exponent form of this would be x to the 20th power. Let's learn a shortcut so that we don't have to expand these out. So if we try to summarize this and try to point out a shortcut that works, let's look at that last example. We had x to the 5th all to the 4th power. We talked about how that's 4 groups of 5 x's to leave us a total of x to the 20th. Hopefully what you noticed is that those initial exponents and that final exponent came from multiplying those together. Again, groups of 5 groups of 4, 4 groups of 5. So the power rule, or when you raise an exponent to an exponent, looks like keeping your base and then multiplying your exponents. So a shorthand way of saying that would be a to the m all to the nth power would look like keeping your base of a and multiplying those exponents. Let's look at some examples. First off, we have these two where we have a term with an exponent all being raised to an exponent. So what the power rule tells me is to keep the base and multiply your exponent. So m to the negative 3rd all squared would equal m to the negative 6th. We'll talk about negative exponents more in this unit, but for now, we'll stop there. 4 to the 3rd all to the 5th power would be equivalent to 4 to the 3 times 5. So that would mean 4 to the 15th power. So what happens if our bases also have coefficients? Luckily, this is a small one, so we can expand that out. We have 3x squared all squared. So what that means is 3x squared times 3x squared. We talked about problems like this when we had the product rule. We can rearrange that to 3 times 3 and then x squared times x squared. So what we see is 3 times 3 would give us 9, and then x squared times x squared would be x to the 4th. Another way to write that of 3 times itself would be 3 squared times x to the 4th. So if we look, it's almost like we're quote unquote distributing that outside exponent to both of the things inside. So we have 3 squared and then x squared squared. Hence our need for the new power rule to get to x to the fourth. So now let's look at some of these more intense examples. Again, I like to think of kind of like distributing out that outside exponent. So we would have a squared all to the third power, b to the fourth all to the third power, and then a c by itself to the third power. Using our power rule, multiplying those exponents, that would give me a to the sixth, b to the 12th, and c to the third. Remember, I can't go any further because those are different bases. Where people tend to miss the most is also applying that outside exponent to that coefficient. So this would be 6 to the fifth and b to the third to the fifth, giving us a final simplified of 6 to the fifth and b to the 15th. My rule of thumb is if you ever needed to use a calculator, it's probably easiest just to keep it as its base exponent. We could solve for what 6 to the fifth is, and if I do that real quick, 6 to the fifth is equal to 7,776. So these two are the same, but again, if you need to use a calculator, maybe just keep it in its exponent form. Last example, distributing out that 6. I'm going to jump straight to that final answer. So 2 times 6 would give me x to the 12th. 3 times 6 would give me y to the 18th. So let's kind of look at the two main rules that we have so far. In the product rule, you're multiplying bases with exponents. What that means is something like x to the fourth times x to the first. If we expand that out, we see that we get a total of 5 x's. So that rule is you keep the base and add your exponents together. By comparison, if you're taking something all to an additional exponent, we actually multiply those two together. So let's practice some basics using both of these. Here I see m to the second all to the 12th. That's the power rule, so I would need to multiply the exponents. By comparison, in the second example, I am multiplying two things together, so I know that I would add the exponents to get x to the 15th. Even when you have numerical bases, you still keep them. I don't actually multiply 7 and 7. I have 45 sevens and 2 sevens to give me a total of 47 sevens. They didn't change to 7 times 7. They still stay sevens. Number 2, if you have more going on, with the power rule, you distribute that out. So 5 to the 7th, x to the 7. Whereas if you have coefficients, you would actually multiply them together and add those exponents. So 52 plus 13 would give me 65. Don't worry, with more practice on this, it becomes very manageable and easy. So you got this. Go practice it on your own, and good luck.